Okay, for 11.3 day 2, I just wanted to, the video is getting a little bit long just because I went through a lot of examples. I just wanted to finish up with a couple more examples here and a new concept, and it's really not that new actually. So, regular polygons, what do we know about them? Well, we know that all sides are the same. And we know that, well, if they're regular, all these angles are actually going to be the same here. So, because all their angles are congruent and all their side lengths are proportional, we know that they are going to be similar. So, what we're going to do is apply the concepts from yesterday to regular polygons of the same, with the same amount of side lengths here. All right, this is a great question here. I really like this one. We got some gazebos here. The floor of a gazebo shown is a regular octagon, okay? And each side of the floor is 8 feet. So this is our gazebo here. I'm gonna draw our gazebo. Pictures are really helpful when you guys are doing these problems. If you guys haven't realized that yet, actually, I'm gonna need a second gazebo because I have like a little mini model here. I know that because I've done this question before. Okay, so 8 feet, and the area is 309 square feet. So I'm just labeling my information here. Okay, you build a small model in the shape of a regular octagon. So since these are both regular, they're going to be similar. I know that because they're regular polygons with the same number of sides. The perimeter of the floor is 24 inches. So, I'm going to write that down. Perimeter equals 24 inches. Now, I already noticed something here in inches, and I have feet. Okay, so that's something to keep in mind. Find the area of the floor of the model gazebo to the nearest tenth of a square inch. And underline that right there. We want the area of the model gazebo. Okay, so what I need to do here is I need to find the ratio of their side lengths. So, this here would be 3 inches, and this here would be 8 times 12. So the side of the mini gazebo is 3 inches, and then 8 times 12, converting this to inches, is 96 inches. So the ratio is 3 to 96, which is 1 over 32. So this is the ratio of the side lengths. And then I want to know the ratio of the areas. Okay, well, 1 over 32, and I'm going to square that. This is going to give me the ratio of the areas. That's 1 over 1024. So this is ratio of areas. Okay. All right, well, I have the area of the large one. I need the area of the small one. So let's put area, we'll call this area of the small one. And we'll do that over 309. We will cross multiply. 1024, area of the small one, equals 309. Divide by 1024. So 309 divided by, I'm actually just going to leave that as it is right now. And the reason for that is, this is in square feet, which is less than 1 square foot. It's about 1/4, 1/3 of a square foot. And keep in mind, this is a very small model here. Okay, so I want it in square inches. So what I'm going to do is I'm going to use a conversion. So 309 feet. Now the conversion that I want, I need feet squared on the bottom, or square feet on the bottom. I need square inches on the top. Okay, because the end result has to be in square inches, so the square feet have to cancel. So how many square feet or square inches in a square foot? Well, let's figure that out. 1 foot by 1 foot. So that's 1 square foot. If I change that to inches, 12 inches is 1 is 1 foot, so 12 inches is 1 foot, and so that's 144 square inches is the equivalent of 1 square foot. So my conversion is 144 square inches to 1 square foot. And what we can do is we can do 309, so the feet squared cancel up there. 309 times 144 is 44,496 divided by 1024, and that leaves me with 43.5 square inches, and that would be your answer for the area of the model gazebo, the floor of the model gazebo. So this is a very large multi-step question, which is why I saved it for day 2. Very good question though. I'm going to go over 2 more sample questions for you guys. The ratio of the areas of 2 regular decagons is 20 to 36. What is the ratio of their corresponding side lengths in simplest radical form? Okay, there's a lot there again. Big mouthful. We have 2 regular decagons. That's 10 sides, and that's the ratio of their area. So I'm not even going to draw a picture of this. I'm just going to see what we can do here. So we have the ratio of the areas. We need the ratio of the side lengths. Okay, so all right, what I'm going to do is first reduce. Always reduce your fractions. I'm going to divide by 4. That gives me 5. I'm going to divide by 9. That gives me, or divide 36 divided by 4. That gives you 9. Now, to get to the ratio of the corresponding side lengths, I need to square root both sides. So I have root 5 divided by root 9. Now, last year, you may have learned how to simplify radicals, or this year, I think I taught you guys how to simplify radicals. This is called rationalizing the denominator. We have root, wait a second, root 9 is, I don't need to do this. Awesome. Okay. Root 9 is just 3. Normally, I'd say we'd have to rationalize the denominator, but square root of 9 is 3. So you can have a root on the top, but you can't have a root on the bottom. So what I was setting up was rationalizing the denominator to get rid of that, but I don't actually need to do that. So there you go. All right, number 3, last question. Rectangle 1 and 2 are similar. The perimeter of rectangle 1 is 66. The perimeter of rectangle 2 is 35. Oh, okay. Wait, oh, okay. This is inches. Okay, I'm going to draw that picture here. So perimeter, 66 inches. And then rectangle 2 is a really big rectangle, 35 feet long. And this is in feet, 20 feet wide. Show the steps you use to find the ratio of the areas, then find the ratio of the area of rectangle 1. Okay, well, I'm going to need the area of rectangle number 2, and 700 square feet. Might want to convert that later, I don't know yet. Well, let's convert everything to inches. I think it'll be a little bit easier. So 20 times 12 is 240 inches, and 35 times 12 is 420 inches. So I have 66 to 240 if I'm comparing their side lengths. And let's just divide by 2, 33 to 120, divide by 3, 11 to 40. Okay. So with that being said, I now have my ratio of their side lengths is 11 to 40. If I square this, this will give me the ratio of the areas, 121 over 1600. Now, this answer, if I use 700 square feet, then my area in my other picture will be in square feet. So let's see if the question says, show the steps you use, then find the area of rectangle 1. Well, it doesn't say, so let's just do it in square feet, I guess. Area over 700. So 700 times 121. Just doing some cross multiplying here. 84700 equals 1600A. Divide by 1600, and my answer is 52.94, and this is square feet. So keep in mind, if they had said in square inches, I'd have to convert the 700 into square inches and then do that. But the book didn't say, so we're just going to leave it as that. Don't just double check here. Yeah, okay, cool, that works. All right, and like I said, just take care of anything that you didn't take care of from yesterday for your homework. Not going to do any new assignments since this stuff is a little tricky, and I wanted to give you guys 2 days to process through this material. Thank you guys for tuning in, and I will see you next